All right, so today we're going to be looking at Unit 3, Notes number 4. And we're going to be looking at all the parent functions. So we're going to be looking at the parent functions for linear, quadratic, and exponential functions. So that's going to be our goal today, is to look at the parent functions for those three types of functions and learn about some key characteristics of those functions. So let's look at the first one. So the first one we have says fill out the input and output table and graph the given function. So we have f of x equals x. This right here is going to be our linear parent function. Okay, so just f of x equals x. This can also be written as y equals x. Okay, those are the same thing. This right here, remember, just tells us that, hey, this is a function. So we're going to first fill out our input and output table. And remember, when we make our input and output table, right now we're starting with -2, -1, 0, 1, and 2. And now those are the inputs that we're going to use. So we're going to take that -2, plug it in for my x, because that's my input. So when I do that, I'll have f of -2, because that's my input, putting that in, equals, well, instead of x, now we have -2. Well, guess what? That's all it's going to equal. We can't change that at all, so our f of x, f of 2, -2 equals -2. Now we're going to plug in the -1. So we're going to have f of -1 is equal to, instead of x, it becomes a -1. We're going to do the same for f of 0. On 7x, it becomes a 0. I'm sure you guys are seeing the pattern right now. Okay, we're going to do the same thing with f of 1, because we're taking that 1 and plugging it in. Well, in 7x, now it just becomes a 1. And then last but not least, we're going to take that 2 and plug it in. And we'll have f of 2 is equal to, instead of x, it becomes a 2. It's a weird looking 2, but you know what I mean. So now we're going to write those as coordinate points. So we're going to have -2, 2, -2, -2. Remember, this is just my x and my y. We're going to have -1, -1, 0, 0, 1, 1, and 2, 2. Okay, so we're going to graph those points, and then we're going to talk about the graph. So our first point is a -2, 2, or -2, -2. Then we had -1, -1, 0, 0, 1, 1, and 2, 2. So we're going to connect our points with a nice straight line. Yours is probably going to look a little bit better than mine. Actually, probably not, because that looks pretty good. So from here, okay, we've got our nice perfect graph, and we're going to look at some information. All right, so this says, this is the parent function for all linear functions. That means all linear functions come right from that function. Okay, so this is the first linear function we're looking at. It says the parent function accepts all real numbers as inputs and can have all real numbers as outputs too. Now remember, inputs is the same as our domain, and that's also our x values. Okay, we're going to be talking about domain and our inputs a lot, just like we've done on the first couple sets of notes too. Domain, x values, all of that is our inputs. Okay, so that means all real numbers can be as inputs. That means if I look at my inputs right here, remember x is our inputs, I can put any number into the function. I can add any number in there, and I will get an output to go with it. Okay, so that means all real numbers for our domain. So our domain, our input, that's going to be all real numbers. All right. And then the next part says, and can have all real numbers as outputs too. Remember, our outputs are our range. Okay. It's also our y values. Okay, so that means all real numbers. That means I can put any number into the function and I can get literally any number out of the function. Okay, I can put in a positive number, I'll get a positive number out. I can put in a negative number, I'll get a negative number out. Okay, so that's also going to be, for my range, all real numbers. Okay, and then the parent function has a y-intercept of 0, 0 and an x-intercept of 0, 0. If I look at my graph, it hits the x and y-axis both at 0, 0. That's also the origin. So our x-intercept, 0, 0. That should be a parentheses. There we go. And our y-intercept is 0, 0 at the origin. And what type of function is this? We said this is our linear parent function. Okay, so looking at this, guys, this little section right here, this table, the graph, and this right here, okay, that is a test question. Okay, so you will have to have these parent functions memorized. Okay, and our first one is the linear parent function. Okay, so now we're going to look at our quadratic and then our exponential one. So looking at this one, okay, it says fill out the input and output table and graph the given function. So we have f of x equals x squared. Okay, so our inputs are still going to be the same. So remember, x is our inputs, -2, -1, 0, 1, and 2. And we're going to plug all of those into the function. So we're going to start with -2. Now, when we plug this into the function, we have to use parentheses. So I'll have f of -2 equals -2 squared. You have to use the parentheses when you plug this in. So -2 squared, -2 times -2 equals a +4. So we're going to have a 4 for our output. Remember, f of x is the same as y for my outputs. We're going to do the same thing with a -1. So now we're going to have f of -1 equals -1 squared. Instead of x squared, it becomes a -1 squared. Well, -1 squared, -1 times -1 gives me a +1. Do the same thing with the 0. So we're going to have f of 0 is going to equal, instead of x squared, it becomes 0 squared, which is just 0. So our output's going to be 0. Plug in the 1. We're going to do this over and over and over. Guys, you need to make sure you are showing all of this work, okay? That way, if you make a mistake, I can go in and check your work, okay, and we can figure out what you did wrong. So we're going to have f of 1 equals 1 squared. Well, 1 squared gives me 1, because 1 times 1 is 1. And then last but not least, I hope you're seeing the pattern here. We're going to have f of 2. Write it over here because I ran out of room. And instead of x squared, it becomes 2 squared. Notice I'm using parentheses. And 2 squared gives me 4. So my output's going to be a 4. So we put all those into the function, we get our outputs, and now we can make coordinate points so we can graph. So I'll have a -2, 4. I'll have a -1, 1. Remember, see -1 and 1. I'll have 0, 0. 1, 1. And then 2, 4. Okay, and we're going to plot all of our points. So -2, 4. -1, 1. 0, 0. Then we had +1, 1. And then +2, 4. And we're going to connect those. It's going to give you a nice curve. Okay, and we actually call this a parabola. Okay, so anytime we have a graph that looks like this, it's called a parabola. Now, what do we notice about the graph? The thing I want to point out, and I want everybody to notice, is all of my outputs are positive. Okay, see how I've got positive 4, positive 1, 0, positive 1, and positive 4 again. Even though my inputs were negative, I got positives for my output. So all of my outputs are positive, okay? And that's going to be important when we talk about some of our key characteristics. Now, remember, this is a test question. You have to have these memorized, okay? So this says this is a parent function for all quadratic functions. So that means this is our quadratic function type. Anytime we see an exponent of a 2, then we know it's going to be quadratic. So looking at this, it says the parent function accepts all real numbers as inputs. So that, remember, my inputs are my x's, and it's also my domain. And when I say all real numbers, that means I can put any number into the function. See how they're all negative and positive? Any number can go into the function. So my domain is all real numbers. Okay, and as for our outputs, remember our outputs are a y. Now this says all real numbers greater than or equal to 0. Okay, greater than or equal to 0. And the reason it's greater than or equal to 0 is, remember, my y's, if we look at this, they're all positive. I don't have any negative numbers. Okay, I have 0 and then all positives. And if you look at my graph, see how this is all in the positive area. There's nothing down here in this negative. Okay, it's all in the positive area. Therefore, my range is going to be y is greater than or equal to 0. Okay, because it's everything that's greater than or equal to 0. And that's because we only got positive answers for my outputs. And then the last part says the parent function has a y-intercept of 0, 0, and an x-intercept of 0, 0. Because if we look at our graph, it is the x and y-axis right there at 0, 0. 0, 0, 0, 0. All right. So that's everything you need to know about the quadratic parent function. Lots of information, but it's going to look the exact same every single time. All right, last but not least, we have our exponential parent function. Okay, so we have f of x equals 2 to the power of x. Anytime your exponent is an x, that means it's going to be exponential. Okay, so our inputs are still going to be -2, -1, 0, 1, and 2. And we are going to put all of those into the function. So starting with a -2, we'll have f of -2 equals 2 to the -2. We have a negative exponent, so that means we got to flip it. Remember this, everything from unit 2. So it's going to be 1 over 2 squared. And 1 divided by 2 squared, well, 2 squared gives me 1 over 4. Okay, you can also put that into your calculator if you are struggling, like on a test or quiz, and you can't remember, put it in your calculator. So we'll have f of x equals 1/4 for that one. Okay, remember this is my outputs and my y's. Okay, do the same thing with the -1. We'll have f of -1 equals 2 to the -1. Well, anytime we have a negative exponent, that means we got to flip it. So it becomes 1 over 2 to the first. Well, 2 to the first is just 2. So I'll have 1/2 for this one. And we're just going to keep going on. And remember, you can put these into the calculator too if you're struggling with like our exponent laws. So now we'll have f of 0 equals 2 to the 0th power. Well, I hope you remember anything to the 0th power is going to give me 1. Okay, anything to the 0 power always equals 1. The next one, we're going to have f of 1. So f of 1 is equal to 2 to the first. 2 to the first equals 2. last but not least, remember, anything to itself down here is always going to equal itself, or anything to 1 is always going to equal itself. And then last but not least, we'll have 2. So we're going to have f of 2. It's going to equal, instead of 2 to the x, it becomes 2 squared. And 2 squared gives me 4. So then we'll have the points for -2 and 1/4, -1 and 1/2, 0 and 1, and 1, 2, and then 2, 4. All right. So we are going to plot all these points. So -2 and 1/4, -1 and 1/2, 0, 1, 1, 2, and 2, 4. So when we graph this, and this is going to be the thing I want you to notice, that it's never going to hit the x-axis. So when you graph this, you cannot touch the x-axis. See how it gets really, really close, but it's never actually going to touch the x-axis. And you can put this in your calculator, and the calculator will do the same thing. Gets really close, but never quite there. Okay, so what do we notice about the graph? It never, that's supposed to be a V, and never. Try again. Hits the x-axis. Okay, and I want you to star this, highlight it, do whatever you need to do, because that is going to be a big thing for our exponential functions. So, looking at our key information, we're going to fill out our chart, and remember, this is on your test, so you have to have these memorized. So, looking at this, it says this is a parent function for all exponential functions, so function type, exponential. The parent function accepts all real numbers as inputs. Remember, all real numbers. Okay, means I can put any number into the function. See how they're positive and negative? Okay, so all real numbers for my domain, just like every other function. Okay, and if we look at this, it says can have all real numbers as outputs too. This is actually wrong. I messed up on this. Okay, this is definitely a typo. Scribble that out. Scribble, scribble, scribble. Okay, it should say can have all numbers greater than 0. Okay, because if we look at our graph, see how it gets really, really close to 0, but never actually touches 0, and it never has any negative numbers. Therefore, our outputs can always be greater than 0. So our range, or our outputs, remember these are outputs, are always going to be y is greater than 0. Because it gets really, really close to the x-axis, but never actually touches it. And then last but not least, it says the parent function has a y-intercept of 0, 1. And whoops, totally missed that circle. If we look at the graph, it does go through at 0, 1. And then it says, and does not have an x-intercept. And if we look at our graph, it gets really, really close to the x-axis, but never actually crosses it. Therefore, it doesn't have one. So we're going to write none for our x-intercept. All right, so remember, we have to have these memorized. We are going to practice these a lot in our warm-ups, and you'll see it on your homework. There's no homework for this assignment, so you need to be working on if you have any homework that you need to finish from past classes or past sets of notes. Okay? All right, if you have any questions, please make sure you're asking.